Hello everyone, you're welcome to solve this nice math problem, which is 2 to the power 11 plus 4 to the power 11 plus 8 to the power 11 divided by 8 to the power 11 minus 1. So how do we solve this math problem? So let's prevent a solution from here. Now, we have 2 to the power 11 plus 4 to the power 11 plus 8 to the power 11 divided by 8 to the power 11 minus 1. We can express 4 to the power 11 as, now, this is 2 to the power 11 plus 4 can be expressed as 2 to the power 2 raised to the power 11 plus we can express 8 as 2 to the power 3. So this is plus 2 to the power 3 raised to the power 11. Then divided by, we can express 8 to the power 11 as 2 to the power 3 raised to the power 11, subtract 1. Now, the next step is that 2 to the power 2 raised to the power 11 and 2 to the power 3 raised to the power 11. This is in the form of a to the power n raised to the power m, which you can express as a raised to the power m raised to the power n. Now, applying this exponent property from here, this is the same thing as 2 to the power 11 plus 2 to the power 11 squared, then plus 2 to the power 11 raised to the power 3 divided by, this is 2 to the power 11 raised to the power 3 minus 1. The next step is that we can write 2 to the power 11 be equal to x. So that here we have x in the numerator part, we are going to have x plus x squared plus x to the power 3 divided by x to the power 3 minus 1, of which you can express this as x to the power 3 minus 1 to the power 3. So in this case, x to the power 3 minus 1 to the power 3, this is the difference of two cubes expressed as a to the power 3 minus b to the power 3. And this is the same thing as a minus b, a squared plus ab plus b squared. Applying this identity, then this implies that in the numerator we have, this is the same thing as x to the power 3 plus x squared plus x divided by, now here we'll have x to the power 3 minus 1 to the power 3. This is the same thing as x minus 1. Then here we have x squared plus x, then plus, here we have 1 squared, which is 1. Now, in the numerator, we have x to the power 3 plus x squared plus x. And in the denominator, we have x minus 1 times x squared plus x plus 1. Now, we can factor out x is common in the numerator, so that now we have x into the parentheses. This is the same thing as x squared plus x, then plus 1, divided by the denominator part here. This is the same thing as x minus 1. This is x squared plus x plus 1. So you can see clearly x squared plus x plus 1 in the numerator, and denominator x squared plus x plus 1, this is common, so we can simplify here, and this is equal to x over x minus 1. Now, if you recall, we assigned that, right, 2 to the power of 11 be equal to x. So let's substitute this so that we have in the numerator 2 to the power 11 over 2 to the power 11 minus 1. Now, this implies that 2 to the power of 11, this is the same thing as 2 to the power 10 plus 1. And 2 to the power 10 plus 1. This is in the form of a to the power n plus m, which we can express as a to the power n times a to the power m. Let's apply this exponent property so that here in the numerator we'll have 2 to the power 10 times 2 to the power 1, everything here, divided by 2 to the power 10, then times 2 to the power 1, subtract 1. Again here, 2 to the power 10, this is the same thing as 1024. So this implies that in the numerator, we have 1024 times 2 divided by 1024 here times 2, then subtract 1. So this is the same thing as 1024. That is 1024 times 2. 4 times 2, this is 8. 2 times 2, this is 4. 0 times 2, this is 0. 1 times 2, this is 2. So in the numerator part, we have 2048 divided by, in the denominator, we have 2048 subtract 1. And therefore, we are going to have 2048 divided by 2048 minus 1. This is 2047. And this is the solution to this math problem. So kindly follow the steps. If you have alternative formulas, kindly showcase them in the comment section. See you in the next video.